G'day, I'm Ian Smith and I'm close to finishing my 24-foot Ranger class gaff rigged sloop. So it's late in the piece to be starting to talk about the lead ballast keel, but that's what I'm going to show you today. I'm going to show you how I lofted it, that is, drawing the plan out full size, and how I built the plug or pattern to send to the foundry. With most Carvel plank boats, the lead keel is fitted early in the construction. I knew I wouldn't have enough height in my shed to do this. The timber keel is just off the floor now, and there's still 2 feet of lead and timber deadwood to be fitted underneath. I'll be doing this at the boatyard just prior to launching. When you build to designer's plans, you'll usually have enough detailed drawings of the ballast keel, and you'll usually loft this out when you loft the entire boat. My colleague Simon Sadubin and I measured up the original boat and lofted it out from our measurements back in about 2003. Then Simon drew up the lines plan from our lofting, but we didn't do a detailed lofting of the ballast keel at that time. Lofting is drawing the plans full size so that you can make patterns of parts of the boat, chiefly the station mould shapes around which you will bend the planking. Back in 2003 it never occurred to me to film this lofting, so I won't be able to explain it using this boat as an example, but in my YouTube series on traditional clinker planking, the first 2 episodes are about lofting, which will give you the concept, even though the subject was a small dinghy. I've also explained it several times in books. My wooden boat building book combined my Sydney Wooden Boat School manuals for several different types of construction, and each has a section on lofting. I've also gone into it in my open boat book, showing how I lofted my historical replica 18-footer Britannia. They're both available from sydneywoodenboatschool.com.au. Our original lofting didn't have enough detail of the ballast keel. What there was spread out over a couple of large sheets of chipboard, and with less room these days, it was easier to draw out a new grid and add the info from our tracings. It all fitted on one sheet. A lofting grid needs to be accurate. I laid out a straight baseline and all the parallel water lines, then drew in a vertical line that was exactly at right angles by this method. Make equidistant marks out from your starting point with a basic compass. Then, extending the compass, mark 2 intersecting arcs from these points. A line from here to your starting point will be exactly 90 degrees to the baseline. The rest of the grid can be filled in by accurate measurement. Only station 3 goes through the ballast keel on the original lofting, so I added in more vertical stations, stations 2 1/4 to 3 3/4, and more horizontal waterlines for more detail. I got our original mylar tracings, and by pricking through with a nail, I transferred the details of the sections at the original station positions for stations 2, 3 and 4, spanning the area of the ballast keel, until I'd copied all of the details on our original lofting. So I had the shape of the wooden keel down through the deadwood and the lead keel to the bottom of the profile, and the width of the bottom of the profile all the way along. I plotted out the measurements from these sections to a longitudinal plan view on the baseline, and connected these points with a penciled line on a fair batten. This enabled me to pick up the measurements known as offsets at the new stations. Using these offsets, I plotted out the new intermediate stations. Now, this is not meant to be a thorough how-to video, so don't worry if you can't get your head around it at this point. Even after lofting 3 or 4 boats, I still needed a textbook handy for the next one. and after that, even occasionally, I still needed to refer to one, especially if I hadn't lofted a boat for a while. Having drawn all the sections at the new stations, I transferred the shapes, with a deduction for the thickness of the cladding, onto plywood offcuts and set them up, upside down, on another piece of plywood representing the top of the keel, which was shaped by plotting out the half-breadths from a centre line spaced out along the slope of the top of the ballast keel, and therefore they needed to stand up at an angle. The lower parts of the keel are straight in section, so I clad the stations in plywood, but used narrow strips of Western red cedar to strip plank the curved upper sections. This is like building a miniature boat. The bottom of the ballast keel was also done in plywood, and after fitting that, I rounded off the corners. Then I faired it all. I used West System epoxy thickened with microspheres and used the bead bog method, which speeds up the process a little. When you sand off the top of the beads, you reach a fair surface quicker than if you'd covered the whole area. And then you fill in between the beads and sand again. Several coats of primer gave a smooth surface. Then the foundry applied their own silver paint. I cast several keels in the late 1980s and early 1990s and had no accidents, but several near misses and a few minor problems. So for the 3 keels I've done since 2000, I've had them done at Central Foundry, who do a superb job. Mine was delivered recently, and now patiently waits in the cradle I made for it, which enables me to move it about. The original Ranger's ballast keel was 1180 kilos. This one came in at 1163. There'll be a little bit of internal ballast as well. I'll be fitting this keel to the boat at the boatyard in a week or so prior to launching later in the year. And you'll certainly see that in a later video. But the next video will be about carving the name into the transom with a big name reveal party. Thanks for watching, and I'll see you next time.